All right. So it's begun the recording.
All right. So we'll start off with our first question. What led you to choose the study of acoustics, signal processing, and computer science applied to music at the University of Pierre and Marie Curie for your PhD? And if you were to do it again, would you have chosen something different?
Yeah, it's a big one. Or should I start in the beginning? So first day, basically, it's funny. My family, there's a bunch of engineers there. My grandfather was an engineer. My father is an engineer. Anyway, so I don't know why. I think since I was 3, I said I was going to be an engineer because, after deciding not to be or deciding to be a fireman, I wanted to be an engineer. Whatever it is, every kid. The problem is, I'm interested in engineering, and I actually eventually became one. But I always wanted to work with music and sound. And obviously, there is something known as audio engineering or sound engineering. That's sometimes not really much engineering. It's a lot of technical knowledge that's very important, but not necessarily engineering in the sense of a university engineering degree. Right. So when you go to engineering, a lot of the musical stuff we do today, I mean, mostly at the time playing pop groups and this kind of stuff. So guitars, amplifiers, synthesizers, it's all electronics.
That's true.
So I will go to electrical engineering. So I will learn all about guitars, amplifiers, synthesizers, and whatever, right? To my surprise, and that's still in many places the case, we don't learn this kind of stuff, even if these devices are always obviously electronic devices, mostly these days computers, etc. It's not something that it's taught really necessarily on an engineer. You see much more technical, theoretical stuff or telecommunications or etc. So this PhD was an opportunity after a master's on analog circuit design. The idea was finally I'll be able to combine this engineering knowledge I have and scientific stuff with sound. And that's why it's actually was done at IRCAM. IRCAM is this Institut de Recherche et Coordination Acoustique Musique. So it is a research institute in center in France, in the middle of Paris actually, where they do this since the 70s. Right, science, engineering, whatever, related to sound, to music performance, to production, etc., etc. And then Paris 6 was the place that delivered the degree, Paris Marie Curie. But the degree itself was, the 5 years I spent there was at IRCAM. So it's a joint agreement they have. Yes, I would do it again. I could have done it at McGill these days, right? At that time, it was not as developed, I guess. But there's other places too that offer similar degrees.
Yeah. Our second question is actually, what was it like authoring one of the first books in the field? Did the lack of previous literature make the process difficult, or alternatively, did it give you freedom to innovate?
It's funny because it's the question of age, right? I was doing my PhD when I did that. So I didn't think about innovation or whatever. There was a need, right? And one of my passions, you can see, I have some few thousands of books on a bunch of different things, and I always like books and whatever. And I still have this tendency of looking for information and I have to get a book or a dictionary before I Google something. But at that time was obviously much more important than today. I always thought that these references are essential. So during my undergrad in engineering, etc., I always had textbooks and whatever that were basic my main tools to understand things. So it was natural to think, well, what about a book in this area? And this is essential because, again, these days is still the same. You Google, you get hundreds, thousands or more results. Where do we start? Okay, you got, it's the first page of Google, the best guide to get you into a subject, not necessarily, right? I mean, So these kind of books, these kind of publications help people. And when I did it, I was kind of doing it for me. So if I were to start this, I would like to see this in a book. Right? So it was a kind of a naivety, right? With just let's do it.
That's really interesting. And I agree with Google. It can be very tricky. The first page is never really reliable. So it's nice to have a solid book that could really be used as a guide. For
if I may, actually,
yes,
there's one thing that's also people take for granted, but it's not necessarily the case, is that there's a lot of stuff that doesn't show up at Google. There is a lot of stuff that doesn't exist necessarily in easy places or at all in the web. And we tend to think that what is there is what exists, and it's not necessarily true. So this is true, obviously, for anybody doing research. It depends on the paper you're looking. You might not find it online. And if you do, sometimes it's not the full thing, it's just a reference, etc., etc. So we need to be aware always that Google is not necessarily 100% the solution, right? Although it's amazing.
Yeah, no, that's true. And actually, just a follow-up from that question, have you noticed more literature on the subject since you've written your books? And have you, like, do you approve of it? Do you think that it's been more appropriate than what you saw before?
Well, it's a question of evolution, right? I mean, well, there's one big fact that happened in the field since I wrote the book, and in part it was I won't claim it was derived from the book, but it was an event that happened in 2001, and the first one I edited was 2000. And they cite this book I co-edited, as one of the references to propose this event. So it was a workshop in one of the biggest conferences in human-computer interaction in 2001. And they proposed a workshop called 9 New Interfaces for Musical Expression. With they selected 14 papers, whatever. It was a very small thing, 1.5 days, I guess, if I remember well. One of maybe 20 or more workshops that happen every year in these conferences. So every year people propose topics, special talks. They happen one day or 1.5 days or 2 days before the conference, just before, where people go invited, and they do sometimes selection, sometimes they invite, and you discuss a topic. So this happened in 2001. So again, it's nice. This is online. You have their proposal for people propose this. And the book is cited as, badly cited by Saga. So this actually became was the catalyzer for this field, at least the way the field exists today. This field existed, music technology exists since the 50s. Not officially as a field, etc., but research in music technology is almost as old as research in computing, basically. Okay. But basically, this interaction with new instruments and computers, etc., started. There's examples in the 80s, already 90s. But in 2001, this was a small event. In 2002, it became an international conference. So this small event was a catalyzer that allowed groups that existed already, but they're not well structured as they are today, to become a field, right? And that became the 9 field in new interfaces for musical expression. And so since then, there's an international conference every year since 2002, and now it's the 21st international conference, right? 20, because 2001 was the workshop. Every year there's dozens or hundreds of papers on this field. So there is an increase, an enormous increase of the literature, basically, in this area. There's a community of several hundred people, basically, whose main attachment is these 9 community. So this is major, and this happened. It was a great and amazing move by these 4 researchers. One is in Canada, actually, Sydney Fells in British Columbia, who came mostly from the HCI field, the human-computer interaction. But there existed already, and this book, for instance, the 2000 book, The Trends in Gestural Control Music, was a kind of state-of-the-art of the computer music side of this area. Right, so NIME in 2001 put together these people from human-computer interaction and computer music, and that what is today basically the conference. So yeah, it's evolving and it's specializing, and then different conferences started from these interaction conferences, like tangible interfaces and etc. So it's a normal process, right? People find common interest, they create a group, and this group starts growing, and then people from this group create new groups, etc., etc.
Yeah, it's really nice how it kind of starts and it creates kind of like an academic community. And something new too. People who may have been studying one subject could now see, well, actually, this is very interesting and ties into their field, and they can enter. So
it kind of creates a legitimacy, right? I mean, you can say, oh, I have a label to attach. I mean, this research existed way before this event. And I mean, there's examples of papers in the early 80s in the Watershed. There was MIDI.
oh,
it's this protocol, and that's amazing. Hello?
Okay. I think you froze a second. Was it just for me, or Maxwell, was it frozen for you too?
It was frozen for me too.
Oh, then could you just repeat the name? MIDI, I missed it. You said MIDI and then you cut off.
So the Watershed basically was MIDI. MIDI is musical instrument digital interface, right? And it's a protocol to communicate between synthesizers that was developed in the 80s, early 80s, 82, 83. And this actually allowed easy connection of devices. Before you could do, but it was not as easy. And that became then one of so you could connect any device, so for instance, my musical device, into a computer, right? Okay. And then I can play this, right, whatever, and the computer makes the sound. And so the instrument is split into something that is an instrument like strings with the body, etc., that you cannot take away. And I mean, you can take the string, but you don't do much. And when you can have the strings here and the equivalent of the sound resonating, the body of the instrument elsewhere in the computer and the micro and the loudspeaker, etc. So you could connect anything to anything. So strings to drums or whatever, and make this kind of hybrid stuff and create instruments that don't have any sense acoustically. Like in the acoustics, I mean, a string that is tighter than another string has a higher frequency, so perceived as a higher pitch, etc. You could now invent whatever relationship you want. A string of this size playing harmonic sounds, or a string of 10 kilometers playing pitches you cannot hear so high there. I mean, there's no more relationship between materials. It's all computer based, right? So this opened up an enormous amount of possibilities, but this is 80s, it's way before the conference and whatever. So there are lots of examples of works in the 80s and the 90s, and there are pioneering works even in the 60s or 50s. Of course, computers were not what they are today, so there are more electronics, etc. But there's research from the 20s basically on new instruments. The theremin is the famous example of a non-contact instrument, two antennas, and play the pitch, the frequency and the amplitude of an oscillator there. But that's 1920s. And people were using these, of course, never became as popular as an acoustic instrument, several issues there. But this exists actually. So it's interesting we don't know more sometimes in pop culture, right? I mean, we should know that it's not so novel.
That's really interesting. So for our next question, it's a follow-up from your first book. So when writing your book, New Digital Musical Instruments, Control and Interaction Beyond the Keyboard with Eduardo R. Miranda, what were the challenges and learning experiences from it, given that you had already written another book at the time?
Yeah, well, it's funny, there's so many discussions about this, but I see two reasons to write a book. It's either you write a book about a totally novel subject, or a subject that's not necessarily totally novel, but a subject where there is no book, and you need exactly these guidelines. How do I start looking? Where should I look at? And there's tutorial papers. And because of the novelty and the lack of resources, you edit a book, right? So you go and you invite a bunch of people who are experts, or you think they are experts. And ideally, these books, you do a certain editing work, so to make these different contributions coherent, right? It's not always the case. So the extreme there would be a conference with proceedings, where you accept papers based on quality, but they don't need to have anything in common except for the general topic, right? So this first book I co-edited in 2000, still at IRCAM at the time. We did a lot of editing. So we put papers in relationship, whatever, but it was still edited in the sense that I wrote one chapter, co-wrote, and then other people, there are 40 contributors, etc. So this is great, establish the field. But then to teach, you can select, and I still do. I mean, it's amazing. I still use some of these chapters in my classes 20 years later. Right? But you need something called a textbook. And a textbook is what we all know. It's basically something that 1 or 2 or 3 or 5 people maybe write. And it's extremely coherent. It has a perspective. It has a way of, it's really pedagogical, right? To the extent that you might miss a bit on the novelty, the cutting edgeness, whatever, right? Of different people, experts writing. Right? So these are 2 reasons I see of writing a book. And I wrote the first one was an idea, again, not thinking about, I think it would be cool to have a book. I would like to have a book, a co-edited one. And then the second is I need to teach now, and it's important not only to select key contributions, but also to present these in a more coherent view. And that was the second book. And it's a different process. It's a different, I mean, if you ever try this, it's very different. So that was the reason.
Okay. What do you think is the future of electronic instruments and gestural instruments like the theremins?
That's my crystal ball. So I don't know, actually. You see, there's several possibilities, right? And one of the things, and this is something I want to talk at the talk, actually, the MiniScience talk in August, is music is already extremely affected by electronics and computers and digital technology. So independent of these instruments, new instruments and interaction and whatever, that's mainly my field. Today, basically, most of us, we listen to music through some sort of digital device or some sort of streaming service, or, you know, same for video in general, right? So this technology has completely changed the way we experience music, but also the way we think about music, the way we compose music, and sometimes the way we play music. So if you look at the classical domain, right, recordings are basically digital since the 80s, right? And of course, then you have to, it was a CD, and then it was about DAT, whatever. But, you know, we have the technology already there. We use processing effects, we use filterings, we use computers everywhere in this recording, even of very traditional, let's say classical 19th century, early 19th century music, right? So it has an impact on every single aspect of music today. We might still want to listen to music in long plays, in analog equipment, and why not? That's a choice. But, you know, it has dramatically changed the way we experience music. And this has good and bad sides, right? I mean, all the issues about copyrights and payment for, you know, authors and whatever, but has democratized music, right? So at least in a certain perspective. So before, and when I was 20, if you wanted to get pieces of music, whatever, you had to have a cassette and you record, or you know, record from the radio, or you copy from a little play or whatever, right? Today, if you subscribe to, I mean, even without, I mean, go to YouTube, you have millions or I don't know the number, but like several 100 millions, whatever, of songs there, you know, you just click and you have it. So in terms of literacy, I mean, we have access to music and genres and performance that you could not even imagine 30 years ago, right? I mean, it's you could find the long play, and you bought the long play of this guy, and then you're missing 2 long plays from the 10 that they have released or whatever. Today, you click and you have pretty much everything anywhere, including I don't know how many versions in bootlegs and concerts. And this is technology. It's you know, and this is the same for classical music. So you see all these performances of very important classical performers of classical composers from the 1800s, 1900s. This is again possible because of computing technology. Otherwise, we would still need to buy physical supports of I don't know. So this is undeniable, right? We might like it or not. We might think it sounds better or not. We might think it's beautiful or not. We might miss the big painting and drawing on top of the long play because that sounds better, whatever, right? Then, in terms of performance, there are many cases of full new genres that started because of this technology. And for instance, one is sequencing. So people playing with noises and sequencers, etc. This is something that did not necessarily exist, at least at this level, before electronic devices and mostly computers. And this is major. So a lot of the people making music today make music using computers, software like Ableton or equivalent with devices like matrices of buttons like push, etc. It is a very established musical performance and composition, etc. Very, very popular actually, and that's totally technology, right? I mean, eventually people might use an acoustic instrument together with the digital ones, but that's again thanks to technology. Then will it become as popular that we go to concerts and whatever? That's hard to answer because it's not a question of quality of technology, or it's a cultural and economic drive. So why certain things become popular or not, and why people like certain things and not others? I mean, if someone knows the answer, I mean, probably are very rich today, right? Because I mean, it's not easy to foresee what will become popular or not. What's nice is that there is this opportunity now to make music that was not possible. And so that opens a lot of possibilities, for instance, in terms of people with disabilities. Right? If you don't have the normal ability, normal or the standard or the common or most common, for instance, the physical limitations or whatever, you can still interact and perform music that would be perhaps not possible with acoustic instruments because they require certain actions, etc. You cannot just, I don't know, look at your guitar and start playing, right? I mean, but you could look at eye position and then play sequences, etc. And there are several examples, including software we collaborate called AUMI, the augmented musical instrument. That's basically a camera that follows your gaze, and you can basically, play different things, etc. So again, it's opening up new stuff, but it's undeniable that it has changed even traditional musical contexts. And again, they're good and bad in everything. So I think it's just a process, and we should try to influence this process to make it better, more inclusive, etc. Long answer.
Yeah, that's very interesting and very important too. So it's taking some interesting directions, and it looks like for the better. I like the idea of accessibility. That's very interesting. With music technology being a cross-disciplinary field, where there's no limit to what field of study can be applied to music, what area of study was the one that you least expected to have an application to music? Would something like biology, for example, be possible to be applied to the field of music research?
Well, I had a PhD student who was co-supervised by Theo van de Ven from the Department of Chemistry. Right, so it was perhaps, I don't know, the first, I don't know, but one of the early ones, co-supervision between music technology, and chemistry, the Pulp and Paper Center at McGill. And actually that student was materials engineering, right? So someone who had a degree in chemistry and applications to materials, specifically paper manufacturing. And we built sensors for musical instruments and of course for anything else. So position and pressure sensors. So we built the paper, we used different papers and we tried our own types of paper. We characterized, we made measurements of these devices to show how well they actually compare to commercial examples, right? So this is, once I never thought about this in the beginning, I will be working with chemists on chemical processes, whatever, to create black paper, whatever, with carbon at the time, to make sensors that we can then make a sensor that actually is the whole length of the guitar neck, or fits the whole back of the piano keys, etc. Commercially, you might not find the sizes or the electrical characteristics you want, because obviously commercial devices are made for mass production, basically cars in general, right? And so that was a full PhD thesis that happened some 10 years ago. We also collaborated with dentistry because they had a machine to measure material resistance. And one of the papers before, or one of the articles we did before this thesis in chemistry with another student, was comparing commercial sensors that we could buy, 3 or 4 different types. And using this machine so that when you compare, of course, if you press a sensor with your finger, even if you think you're doing exactly the same movement, exactly the same duration, exactly the same force, it's always never, because we are not necessarily machines, right? So we need a machine to actually know that this is exactly the same excitation to the sensor, right? So that you can measure and say, well, they behave similarly or not. And that paper was amazing because it was actually rejected on a conference. We sent it in 2006, yeah, to a conference, and reviews were like, no, it's not amazing. No, it's, what did they say? No, it's lots of data, but there's no conclusion, whatever. Well, they killed the paper. And we never resubmitted, right? And I put it online actually because it was to say, okay, comes a report online. And it has 125 citations in Google Scholar. I mean, gets like 20 citations or 15 citations a year. In engineering, actually, a lot of people cite that report that actually, I don't know why in Google appears as a paper, because I think the version there was a preliminary version, but it's written for the conference and people just cite it. So it's not actually in the conference, but it's still alive, and it's one of my most cited papers in that conference, the NIME conference in 2006. And again, it was thanks to dentistry at McGill, actually, that allowed us to use their machine. I mean, of course, there's nothing to do with dentistry in the application in that case. But the chemistry was, I mean, those processes and characterization could be used for manufacturing in general.
Okay. Oh, yes, sorry, I lost my spot, but actually it follows up on what you just said. What have been the major challenges of working in an interdisciplinary field? What were some of the challenges you faced when you started out your research in the interdisciplinary study of music?
Well, this is another big question. It's, well, starting by saying the word is interdisciplinary. Like it or not, the word is the word. I mean, we might see it through a perspective. So engineers tend to see as systems, and scientists tend to see as maybe models, I don't know. Right. So of course we bring our own view and our own experience and whatever that obviously bias our perception and our cultural values, etc. So, but that is our view. It's not because I see something one way that thing is that way. Right? One thing is multiple, obviously, and allows for these different perspectives. So it shouldn't be a big deal to do interdisciplinary work. So it's very funny that, oh my God, interdisciplinarity is a novel thing. And no, it's not actually. Interdisciplinarity it's basically what should be. So why then disciplinarity became so important? And it's obviously one of the reasons is because to teach someone, right, something, it's important to present from a perspective. I mean, it's very hard to teach something if you present 20 different perspectives at the same time. It's like, hello, right? So we always specialize, and we all have a sequence of classes and courses and etc. that allow us to have a certain coherent view and background, right? That we will use this professionally, etc., etc. So it's important. It's not a criticism of disciplinarity, but disciplinarity it's again, it's very important, but it's not necessarily the end. And actually, to solve a lot of problems, we need to reach across fields. So interdisciplinarity, again, it shouldn't be a big thing. And actually, there are so many levels. I mean, you might be an electrical engineer working with a mechanical engineer, and you do electromechanical devices, or a process engineer that does some electrical control of chemical, and bioengineering, where you have what becomes, in my case, interesting is this combination between engineering and computer science and arts and music. Performance, right? That's more kinesiology or equivalent, but also the performance, the composition, etc., etc. So it's really crossing across the natural sciences and engineering type of research, right? Science and engineering, to the social sciences and humanities or artistic research, right? And there becomes obviously very interesting, but a bit more complex. I mean, if you are in the same, I would say, in the same subfield of natural science and engineering, it's kind of more feasible to do multidisciplinarity, and is more acceptable because there is a lot already. When you cross, it becomes a bit harder because people don't know where to label you, where to place you. And unfortunately, we need to place everybody, even if not consciously, right? I mean, this person is this is in this department, this is in this thing. And again, it's so is it easy to do or not? I think at McGill, we are lucky that we are very free. And this is amazing, and I hope it will continue, and I hope this, it should be universities this way. I mean, a researcher is free, even as a non-tenure, whatever, to decide on their own research, and then you evaluate it on your results, right? And obviously the results then will be a function of the areas you are. So one of the issues with multidisciplinarity, that although we are free, it's hard to value results, right? Because if you are in a field like electrical engineering, you apply, you submit papers to a journal called, for instance, one of the hundreds of journals from the IEEE. IEEE is the International Electronics Engineering, Electrical and Electronic Engineers Institute of Electrical and Electronic Engineers, IEEE. I should know because I'm a member for 30 years. Anyway, but so this is easy, right? You know, this journal is very good and it's hard to get it. But then once you are in interdisciplinary, so some of my papers are there, some of my papers are in music journals, some are in computer music journals, some are in, and then it's hard because people who are in a field and looking at these results and trying to compare and select for prizes or for name it, right? I mean, promotion, whatever. You obviously know better your field, and it's hard to access someone else's things, and it's not uncommon that I get comments like, "Oh, but you know, we can't really evaluate this publication because it's in another field." And these are some limitations of the interdisciplinary thing. Is that, and the research is that actually, I would say, it's passionate. I don't see myself doing another type of research, but there are definitely drawbacks in the sense of you don't progress nearly as fast as you would if you are on a very clear departmental, etc. So it could work both ways, but typically when it goes to selection of candidates or whatever, and they look through the lens of a field or a subfield like natural science and engineering, if you are in between these and social science, it is hard because it's obvious, right? I mean, you're just looking at part of the contribution and you cannot value the other. So I would say there's, it is obvious people should be doing more and more, just because I think that is the way to go further, or at least one way to go further. But there's advantages and there is drawbacks. So one of the main advantages is being able to work with students from whatever background, right? So I had students who are music performers, composers. I have still, right? physicists, electrical engineers, neuroscientists, psychologists, I mean, name it, right? So I don't remember now by heart, but it's like 20 different backgrounds. And they all did a Master's of Arts in Music Tech or a PhD in Music Tech. It's more than 50. Masters and PhD, I supervised or co-supervised, and I don't know how many areas. So this is, for me, it's amazing because everybody brings a perspective that challenges your own preconceptions. So when I talk to composers, and I'm not myself a composer, it forces you to see, to try to understand their perspective. You know, why do they say that? I mean, no, that should be easy, but they say it's not. So why? You know, it's like, well, there's two ways to view that. I mean, either they don't know what they're doing, and that's kind of a bit stupid, right? To imagine that people who spend their time doing something, you know, more than they do what they're doing. And the other is, well, maybe I don't know enough to be able to tell, you know, where is it? And then once you understand, you are able to collaborate. Right. So this, I think, it's a constant remise en question, right? And, you're constantly questioning yourself and what you know and what you don't, and trying to find common ground. And that for me is invaluable. It's really a major, independent of how much you progress or how many prizes you get or whatever. It's not the goal, right? The goal is to I mean, you come to university, I mean, at least some people I know, to learn and to progress and to understand things, not to be celebrated.
Yeah. And what are some of the challenges in building an interdisciplinary course?
Well, it's exactly this thing, right? I mean, I teach this class. It's one of the ones I teach most often. It's called Introduction to Digital Audio. And this is a class that Maxwell took. So he can he can have his own answer to this thing. And this is a class that's a 200 level class for a minor that we offer. That's a minor in science and technology. So Music Tech offers two minors. One is the minor in science and technology, and the other one is musical applications of technology. So the minor science and technology is mostly for people in natural sciences and engineering. So physicists, engineers, computer scientists, whatever, students, right? Who want to later do research in music tech, engineering, computer science, neuroscience, whatever, apply to sound, music, psychology. I mean, it's more technical but there are classes on perception, etc. The other one is for people in arts or music and etc. who want to work with technology, whatever, but they don't want to develop technology. So they will have the concepts or whatever at a level, more applied level. And this will then allow them to use this and be very fluent, whatever, but not necessarily be a developer or build things necessarily. So this course actually is mostly for people in scientific and engineering or computer science. But there's several cases of people coming from music degrees. And some do very well actually in the class. But there is this kind of, you have to think about how to teach this, because you can't just go assuming that everybody has the same background. That would be the case in an engineering degree. You assume people know certain things and you just go from there. And so you have to think about ways to present concepts and whatever from these different perspectives so that everybody kind of gets the essence of what the course is about, right? Without necessarily the same level of details, because you know, it's just a different, you need a different background, right? I mean, some actually manage even at this class to get this background they don't have, at least partially, but it's a challenge, you know, and even in between engineers and scientists, I mean, backgrounds are not necessarily the same. I mean, Maxwell can tell the project we are working together now, right? It's a very engineering the moment now, and Maxwell has a background in computer science and physics, so it's like, oh, all these engineering things, how do they talk about this and whatever? It's very interesting, even in closer fields, I would say, fields that are closer together than music performance and electrical engineering.
Okay. And the last question we have for you is, how has COVID-19 affected your ongoing projects and research?
Yeah, it's interesting because as everybody, right, it stopped. A lot of things stopped because, you know, you can't do certain things. But again, it was an opportunity I don't know, I cannot share a screen, but Maxwell knows a tool that we developed actually last year because of COVID, in a sense, and it's a web application for this class, digital audio. And I used to teach this since 2001, right? I would come and there's a whiteboard, and you know, I would put a signal there, and I would show. So the notion of sampling, right? Sampling is you have an analog signal, so a signal that changes over time, like a sound, like a sinusoid, a sine wave. And you want to create a digital version of the signal so that computers can manipulate, right? Computers cannot play with analog signals. You know, signals need to be sampled and quantized. So I won't describe all the details, but you know, so I would go to the whiteboard and I would draw this, and I would show sampling. It's like taking pictures at a certain time. So the faster you take the pictures, the more information you have. So how fast do you need to take? So this idea of watching a wheel turn in a movie, that the wheel starts turning faster and then turns backwards. And so why it turns backwards if the car is accelerating, right? Well, the notion of aliasing, right? And the notion of quantization and errors, etc. But obviously, it's hard to do a whiteboard thing with everybody in the room if you are distant, right? So we created this tool that's an interactive tool. So you put this, it comes with the whiteboard kind of there, and you play with the parameters yourself, and you see the result and you hear the results. And that was totally because of COVID. So I got two of my master's students and said, well, let's do it. And then I got some of the funding I have for my own research, and we built this, and this is being used like extensively by a bunch of people and whatever. It has become a main tool that wouldn't happen, I think, at least not as fast, at least, if it wouldn't be for COVID, right? It was the need to have something there, and we just did it. And I personally think it's an amazing tool, and allow me even to see things as, oh yeah, that's what happens. Oh, you know, this case is where exactly you're playing at the limit of the parameters and whatever, and you see the effects immediately. So it's like almost having the signals physically in front of you with an oscilloscope and whatever. Of course, with limitations. Right? So that was a major beneficial thing about COVID. I think also another one is I recorded classes, and then half of my class would be pre-recorded and half would be live. And people could then listen to these classes way in advance. They didn't need to be real time listening and then asking questions in real time. So it allowed people to obviously watch multiple times if anybody feels like. But you know, going back and understanding and playing multiple times until you really get. So again, that's something that obviously existed in distant teaching before, but I was not doing, and I plan to continue doing that, even going back to presential thing. Instead of 3 hours me talking, and you know, okay, there's this material already there. Let's discuss this material. Once you already watched, I can go over again fast. So, but focus on the hard parts. Right? Then, of course, other things stopped. I mean, looking at people's movements when they play, whatever, this kind of thing requires people to be in the lab, etc. So if you can't, you can. So it's always good and bad.
That's really nice that you managed to find some positives too that came out of the lockdown here in Montreal and the quarantine. So that's really interesting to hear. Those were all our prepared questions. So I guess now what we're going to do is we're going to fix it up, and I guess Maxwell will edit it and we can send it to the Red Path. We'll cut out, I guess it's still recording now, so we can cut out this part.